For question 26, given that a rational function, so 1 over 2x minus 5. So rational function is our special case for domain and range. Alright, so the first question is ask us to find how to find the domain and range, which is our 5.1. So for the domain, we are looking at our x, which is our denominator cannot equal to 0. So we have to do some calculation. Denominator cannot equal to 0. X cannot take the value of 5 over 2. So when we take this value of 5 over 2, it will make our function undefined. So we managed to get our domain of gx equals to x not equals to 5 over 2. So that will be our domain. Then for range, range also is our special case. So for the range, how we going to see the range? We will close the rational function. So when you want to close the rational function, make sure this rational function is proper fraction. So how we know that is proper or improper? That will be learned in chapter 6. Or we can see the category of numerator here is a constant. So the denominator here is a x. So the power of the x is greater than numerator. Then this is a proper function. So if this is x, linear over linear, then it will be improper. Alright, so the numerator function should be a lower grade than the denominator function. So for this function they give us, this is a proper fraction. So that's why we can close our proper fraction here. We can see outside value here is 0. Means our range y will not getting 0. So our concept here is first calculate on our denominator not equal to 0 in order to find out our domain. So this range is just a basic, so we can look like that. So for question B, they said please show this function is a one-to-one function. So we got two choice. Either we use algebraic method or we use graphical method. So for here I will use algebraic method. Okay, then hence find the G inverse means I have to calculate G inverse also. So I have two tasks here. So in order to find one-to-one function, we will start our assuming say that gx1 will equal to gx2. Means we substitute the first value of x into the function and we substitute the second value of the function. Then we do the simplify the function and then we find out what is our x value. What is our x1? If this x1 can equal back to x2, means this is a one-to-one function. If it cannot equals back to x2, then it cannot. So you have to perform it one by one because this is a show. Show means your step have to write it very clearly. Substitute your x1 here. It will be 1 over 2x1 minus 5. And then 1 over substitute x2 into the function 2x2 minus 5. So how we want to find this x1? How we simplify until we get this x1? We have to move everything to the right hand side. So for this, we inverse first. So 2x1 minus 5 will equals to 2x2 minus 5. So step by step, we show it how we get to the x1. So when I move 5 to the right hand side, it will be adding. So we can simplify here. Simplify here. Positive 5 and negative 5. Alright, then we will move the 2 to the right hand side. So it will divide by 2. So when you divide by 2, I get back to the answer of x2. So when I get this result, x1 equals to x2, then we have to do our conclusion, say that this function gx is a 1-to-1 function. So only 1-to-1 function, it can be inverse. So that's why they say hence. Hence means it got a concept related here. When this gx is 1-to-1, means it can be inverse. So that's why the question asks us, hence, therefore you find your inverse function gx. So for finding inverse function, we'll start g inverse x equals to y. Then we'll inverse the function, it becomes g. Domain become range, range become domain. Then we substitute our y into our function. It will become 1 over 2y minus 5. So what we need to get here is we have to find out what is our y. We have to express our y in terms of x. So once you get your y, that will be represented by your g inverse. So I will cross multiply it, or I will inverse it. So 2y minus 5 will equal to 1 over x. So divide by 2. So before I divide by 2, I get it to the same denominator, divide by 2. So therefore, G inverse is equals to 1 plus 5x over 2x. So don't forget we have to mention out the characteristic of this rational function where denominator cannot equal to 0. So x become cannot equal to 0. So you see 5 marks here. So please take down your marks here. So for the first concept we want to see is here. How we prove our 1-to-1. And then how we simplify until we get the x1. And conclude this is a 1-to-1 function. So for inverse, substitute our y into the function and get to the inverse function here. So for range and domain, I can accept another answer because this one I only state out what the value that we cannot accept. Okay, so I can write this. I can write like this. Negative infinity until 5 over 2, not include that value, then continue 5 over 2 until infinity. So for range, I also can accept negative infinity until 0. Take out the value 0, we cannot accept the value 0, 0 until infinity. So both of them we can accept. Alright, so we continue. We are going to draw our rational function, and in inverse means we're going to use our concept lipat, gores, dan menang lagi satu inverse graph tu. So first of all, we have to set up our x-axis and y-axis correctly. So this is my x-axis. That is not. So I'm doing freehand. So you're using your ruler, x-axis, and then y-axis. So just now our rational function is said our domain x cannot equals to 5 over 2. So we have an asymptote here. Vertical asymptote for our rational function where x is 5 over 2. And when we read out our range, it said y cannot be equal 0. So we have a horizontal asymptote here. Y equals to 0. So this is our vertical asymptote, x equals to 5 over 2, and horizontal asymptote, y equals to 0. So our shape of rational is two curves in opposite quadrant. Two curves in opposite quadrant, whether quadrant 1, 3 or quadrant 2, 4. So we will refer back our rational function here. It is a positive rational. is equals to 1 over 2x minus y. So it's positive rational. So means that the curve will be located at quadrant 1 and 3. So I'm drawing up my curve. So here is my asymptote. I have to go near to it. And then here also is my asymptote. This is my asymptote. I have to go near to it. And then here also my asymptote. So I have to go near to it. This is my first quadrant curve. So same to the third quadrant. So near to the asymptote, and then we curve down to the asymptote here. So I have to prolong our vertical asymptote here. Extend x equals to 5 over 2. Then you notice that you have an intersect here. So when x equals to 0, what is my intersection? 2, 0 plus 5, 2, 0 minus 5, substitute 0 minus 5, so it will negative 1 over 5. So this is my y-intercept. Alright, so for the first graph, draw correct gx with the asymptote with the intercept here, and label. This is our gx. Then we're going to do our inverse. So we will draw a line, y equals to x. So you're going to flip your graph, and then you gores, you tekak keluar inverse function tersebut. Okay, so you try. Okay, so when you reflect your graph, bila awak lipat gores, you reflect your graph, you will notice that your vertical asymptote, it will be get a horizontal asymptote at this point. This is our horizontal asymptote that reflected out. So straight away, we label our graph. This is our y 5 over 2. So when it is a horizontal asymptote, it is x equals to 5 over 2. When it refracted, it becomes y equals to 5 over 2. And then you can see your x-axis is reflected on y-axis. So this is my another vertical asymptote reflected out. So my orange color is reflected out. So you can see, okay, part by part, you see, for this part, we managed to reflect it at here. So we just touch up the graph. We touch up the graph that you get the inverse. And then for this part, you will go to there. This is how you get our reflected. And then we continue for this part. So you can see this part, the graph will going to this side. And then for this asymptote part, it will reflected to there. And then the interception here is same, negative 1 over 5. So therefore, our marks will be go on the first mark, diagram marks for the green color, for the rational graph first, the green color, everything asymptote, two graph, and intercept, and its name, all this. Then second graph, second marks will go for inverse. So don't forget to label your inverse. This is G inverse. With your asymptote label, and with your intercept also label the orange color. Then for the diagram marks, the last mark, it will be a completion of this diagram. So the completion here, we were looking at your label, whether your x-axis label or not, y-axis label or not, and your refraction axis label or not, y equals to x. So it's a label. Check on your label. All together, x-axis, y-axis, refraction axis, origin. Yeah, we miss an origin here. And then check your asymptote. Y equals to 0, x equals to 0. So we have 4 asymptote here. And your name of your graph, Gx, G inverse, all the label. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 things. Okay, so we continue to D. We are going to show that G composite with inverse function of G will get X. So means that we're going to calculate this out until we get the answer of X. So this is how we show, how we perform our working. So G inverse. Substitute our inverse function here. So just now our inverse function is 1 plus 5x over 2x. So after we done substitute our G inverse here, we're going to substitute this thing into our function G again. We'll substitute this into our x in function G. So it will be 1 over 2x minus 5. So substitute in the place of x here. So they are testing us. Do we manage to simplify fraction over fraction? Do we manage to simplify it become a single fraction? Okay, so how we going to do that? We simplify our denominator part first. We make it to the same denominator. So from here, I can see value of 2, I can simplify. So for the denominator part, we have a fraction. So we simplify here. Make it to the same fraction, denominator x. So for 5 here, denominator times x, numerator also times x. So after 1, 5x minus 5x is equal to 1 over x. So how to simplify? 1 divided by 1 over x. So we can write like this. We inverse it, become multiplication. Then the fraction we inverse. The fraction we inverse will become x over 1. Okay, we reverse this fraction. X will become x. Numerator become denominator, denominator become numerator. So we inverse it, it become x over 1. So our answer will equals to x. So this is what they asked us to show. Equals to x. So exactly we can get shown. So we only have 2 marks here. The first mark is how we going to perform our concept of composite and get until to show we get answer x.